Hello, welcome back. Let's finish the question that we started. So part C is asking for the derivative of this quotient here. One way to handle this problem is just using the quotient rule for the top to be 5x squared minus 3 and the bottom to be 4. Or you can use some algebra and simplify this expression, and then that boils down to using only the power rule. Let's just do the algebra first. I'm going to split this quotient into two pieces. One piece is this part of the top divided by the bottom, and the other piece would be minus this part of the top divided by the bottom. This is something we know from algebra. So in other words, I can write this as 5x squared over 4 and minus 3/4. So now this problem boils down to using the power rule for this one. The derivative of f is in fact 10 over, or we can just cancel the 2's here. So in other words, 5 over 2 x only. All right, this is sort of like us detouring the use of the quotient rule. So the question is like, what happens if you use the quotient rule for this problem? Okay, let's just write it precisely. Here we go. So the derivative of f is equal to, since it's a quotient, the derivative of the top, so let me just write precisely, 5x squared minus 4 prime, times the bottom, which is 4. Okay. And then minus the top times the bottom prime, 4 prime, all divided by the square of the bottom. All right, let's simplify. So by using the power rule, the derivative of 5x squared is going to be 5 times 2 times x, which is 10x. And this piece here, negative 4, has a derivative 0. So times 4, I just carry this 4 forward, minus 5x squared minus 3 times the derivative of 4. But again, 4 is a constant, and the derivative of that is 0. And this is all divided by 4 squared. Well, as you can see from here, that this term is in fact 0 because you're multiplying by 0. So essentially you have 10x times 4 divided by 4 squared, which is in fact 5/2 x. And this is the derivative of f. All right, so let's start part D. All right, if we stare at part D, the function is a combination of 3 functions. One is 1 over x, the other one is secant x, and then I have twice of e to the x. So at this moment, I want to step back and remind you some properties of derivatives. First off, well, this is a quotient, so we have a quotient rule that I'm going to use for this piece. But this is a trig function, and I have a specific formula for the derivative of secant, so I'm going to sort of like utilize that. And then this is an exponential function. We learned how to take the derivative of exponential functions, so I'm going to use that property. But for the time being, let's just worry about the derivative of the first piece first. So f prime, let me just write everything clearly here, that f prime is the derivative of 1 over x minus the derivative of secant x minus the derivative of 2e to the x. So here the top function is going to be 1, the bottom function is going to be x. So the derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. And for the derivative of secant x, I'm going to use this formula here, which is secant x tan x. Okay. And for the derivative of the exponential function, so we have a constant multiple in front, we keep that, minus 2 times the derivative of e to the x, which is in fact e to the x. All of these rules are in fact listed in the formula card, which is called the derivatives of functions, basic functions. So you can also use that formula card along the way. So let's simplify the expressions and finalize this question. So the derivative of 1 is going to be 0 because 1 is a constant. So it's 0 minus 1 times the derivative of x, but the derivative of x is just 1. So it's going to be minus 1 over x squared. So that takes care of this quotient here. And we already found the derivatives of the last two pieces, minus 2e to the x. And the conclusion here is that f prime is this brand new function. All right, that's the end of the video. Thanks for watching. I'll see you in another video. Bye.